In this class, we have the last two subtopics to discuss, the Greeks and real options. And this real option focuses on application of option pricing theory in investment appraisal. The Greeks are 5 Greek alphabets used to measure the sensitivity of that option value valued in the previous class to changes in those 5 key variables. I'll explain. So those Greeks are delta, we have theta, rho, vega, and we have gamma. Delta measures the sensitivity of the option value with respect to changes in current market price of the underlying assets. So remember, those are 5 key variables, right? S, E, standard deviation, R, T. Remember, S is current market price of that underlying asset. The underlying asset can be gold, it can be a plot of land, it can be shares in a company. E is the exercise price. Remember our last class, the price they are agreeing to buy or sell in the future. This is standard deviation. Remember the volatility. This is interest rates. This is time to exercising that option. So delta measures the change in option value with respect to this S, current market price, meaning how sensitive is the option value to current market price. So remember, we valued an option, call option, put option in the previous class. Now, how does that option value react when there is a sudden change in current market price, say of the shares? Now, theta measures, let me write it, measures the change in option value. This goes in option value, we can call it C, with respect to change in time. So this Greeks measures sensitivity of the option value. So if there's a change in current market price, how would it affect the option? Theta measures the change in option value with respect to time. Delta measures the change in option value with respect to current market price. Rho measures the change in option value with respect to rate of interest, that's interest rate. You can see that. Vega measures the change in option value with respect to volatility. It just makes sense, right? R, fixed interest rate. V, volatility. That's the standard deviation. This one is not actually fixed because it's a future value. Okay. Now gamma is the frequency of change of delta. So this one measures the rate at which delta changes. So this delta is represented as ND1. Gamma measures the rate of change in delta to the underlying asset price. Okay, this is the underlying asset price, the S, the current market price. So like I said, this ND1 is what we're going to focus on, and so that leads to a subtopic under the Greeks called delta hedging. It's going to show delta hedging. ND1. Just clean this off because the bracket is better there. ND1. So delta hedging, what does delta hedging mean? Delta hedging means you are guiding against risk. Okay, and that risk is the fluctuation in prices. The prices of the assets. You know, there's an asset that this whole option thing is because of a particular asset that you're protecting. You don't want to lose money, you don't want to lose value. So delta hedging, the concept of delta hedging is to guide against fluctuations in prices, the risk attached to fluctuations in prices. Okay, so there's a particular formula or 2 important formulas that you need to know under this delta hedging, because they can ask you to calculate the number of contracts you need to delta hedge. It's in that question that we're going to solve now. So number of contracts or number of option contracts required to delta hedge, that's what it means by ND1, is equal to underlying asset. That's what's the value of that underlying asset, the quantity, maybe 10 plots of land, or maybe 100,000 shares, like in that question, or maybe 50 barrels of crude oil, all over ND1. And don't forget, we actually did ND1 in the previous class. And remember I said ND1 is the probability of deviation in the current market price. It's actually easy. It's just this financial terminology that makes it look like a big deal. So every asset has a current market price, S. That was represented as S. So D1 is the deviation. Because the fact that something is 50,000, of course, it's not going to remain 50,000. D1 is the deviation, is the rate of deviation. It can deviate by maybe 0.006%. Then ND1, by the time you put ND1, is the probability of deviation. Okay, so maybe a financial analyst can say, oh, it's going to deviate by, the deviation might be like 0.001%, but then what's the chance, what's the probability? It could be like 50%, it could be like 90%, that's high, right? So, I digress, I'm just trying to explain what ND1 is. So the number of contracts required to delta hedge on an asset is the underlying asset divided by ND1. You also need to know this formula, that this is the first formula. ND1 minus 1 is equal to put option delta. Okay, so we're assuming this is a call option delta. Minus 1 will give you a put option delta. If you bring this minus 1 here, it's going to be ND1 plus put option delta will be equal to 1. Remember that we have two types of options, call option and put option. Let's solve one question to explain this concept. Briefly discuss the meaning and importance of the term delta, theta, and vega, also known as kappa or lambda in option pricing. That's the A part of the question. B, assume that your company has invested in 100,000 shares of Uniglo PLC, a manufacturer of light bulbs. You are concerned. Always try to understand and internalize every question. So they say your company has invested in 100,000 shares of Uniglo PLC, a manufacturer of light bulbs. You are concerned about the recent volatility of Uniglo's share price due to the unpredictable weather in the United Kingdom. So what is the underlying asset here? It's not bulbs, it's the 100,000 shares, okay? You see that they're not giving you those information like underlying asset is this. It's from your understanding of the question that you will interpret these 5 variables. You wish to protect your company's investment. That's the 100,000 shares that your company has bought in Uniglo, right? From possible fall. That's what we call delta hedging. So you wish to protect your company's investment from a possible fall in Uniglo's share price until winter in 3 months' time. Let's start defining our variables. T is 3. But do not wish to sell the shares at present. No dividends are due to be paid by Uniglo during the next 3 months. Then they give you the market data. Uniglo's current share price, you can see 200 pence. 200 pence is £2. Okay, but just solving 200 pence. It's like them saying 200 kobo because 100 pence is £1. Okay, so 200 pence is £2. Then the call option exercise price is 220 pence. So you have gone to those option dealers or option people, and then they told that, oh, in the future, somebody wants to sell an option and said in the future the exercise price will be 220 pence. That's £2.20. Time to expire 3 months, which they've given in the question, right? Interest rates 6%. Volatility of Uniglo's shares 50%. That's the risk, standard deviation per year. Assume that option contracts are for the purchase or sale of 1,000 shares. Remember in the introductory class where we said we have exchange traded options, ETO, and option pricing over the counter. Sorry, OTC, over the counter. So this one is telling you that it is an ETO, exchange traded options. That's the one you go to the registered organizations to buy because it is standardized, it's not customized. In the bank, they can customize it for you. Maybe you need 5,657.5 contracts, they can customize. But this one, they're telling you is an important information because you will see how it will affect your answer. Assume that the option contracts are for the purchase or sale of units of 1,000 shares. Required, devise a delta hedge that is expected to protect the investments against changes in the share price until winter. Delta may be estimated using ND1, that's 8 marks. Then number 2, comment upon whether or not such a hedge is likely to be totally unsuccessful. That's 2 marks. So plus the A part, when it says you explain delta with this part and the C part, it's all 15 marks. So an option pricing question was examined in November 2022 diet, and I think it was 15 marks. Definitely, it's not going to be in section B, it's always in section C. But your knowledge of option pricing, because option pricing is a topic that if you don't know it, you don't know it. There are so many formulas, and you don't really have much to do with understanding the concepts. You just have to learn the steps and the formulas. But if you know it, you can just help yourself with 15 marks, and that's a huge chunk out of 50 marks to pass the paper. So I think it's worth it learning this topic. Okay, so we are asked to briefly discuss the term delta, theta, and vega, which is just 5 marks. So you just say delta, let me write it. So you just say delta measures the change in option value with respect to a change or fluctuations in current market price of the underlying assets. Do you understand? It's just 5 marks for the 3 explanations, so you don't have to write too many stories. You can say the, delta is represented as ND1. Did I mention call option delta? Call option delta is ND1, like positive ND1. Then put option delta is negative ND1. Right. No, call means buy, put means sell. Then the big part, that's the second one, sorry. I think it's theta. You write all these long stories. Theta measures the change in option value with respect to time to exercise the option. Then C, vega, all that. Vega measures the change in option value with respect to a change in volatility or standard deviation or risk attached to the underlying asset. Very simple. You get your 5 marks. Now, the B part of the question, devise a delta hedge that is expected to protect the investment against the share price until winter. When you see that delta hedge, remember the formula under delta hedge that I told you. You just start with your formula, state your formula so the formula can guide you. When you have a formula, you go and start looking for the variables. Okay. So we say number of contracts required to delta hedge is equal to underlying asset quantity divided by ND1. Remember, this can represent delta hedging, right? So that's it. Then you go and start looking for, this is what you're actually looking for, the number of contracts you require to delta hedge. So you devise a delta hedge that is expected. That means how many contracts are you buying to protect. Let's just look at contract as a certificate. Okay. The thing is that in the class they might not explain it to you like this, but you have to just try to allow it to make sense to you. Look at each option contract as a certificate. You come to me that you want to protect your investment, so I'll give you 1 contract per share, something like that. What is the underlying asset? It's given in the question as 100,000. Then what is ND1? We don't know, so we have to recall our formula for ND1, which is which should actually start from D1. Okay, remember that ND1 formula is actually table value plus or minus 0.5. Let me write that correctly. It says ND1 equals to 0.5 plus or minus table value, depending on whether the table value is greater than 0 or less than 0. Greater than 0 or less than 0. Remember our former class. But you have to get D1. Okay, you need D1 to get ND1. I remember the D1 formula, natural log S over E plus R plus 0.5 standard deviation square, am I right? All over standard deviation root t. The formula doesn't look complete. T is missing here. Now, what are your variables? Remember, you define your variables somewhere, okay? Okay, in the question, we gave you the current price, which is S, as what? 200p. They gave you E as 220p. What else do we have here? R, 6%. Is it 6%? Yes, 6%. That's 0.06. We have standard deviation as 50%. As 50%, that's 0.5. Then we have T as 3 months. And don't use 3 months. Always use 3 over 12. Do you understand? Like put it in years, convert to years. So it's 3 over 12. So that would be 0.3. Let me take my calculator. 3 divided by 12, 0.25. 0.25. I thought it was 0.333. It's 4 months that is 0.333, which was what we used in the previous example. Put your variables inside the formula and you're done. But if you don't know, you don't know. That's why people avoid option pricing forex. Our next class will be forex. People avoid option pricing forex because they don't know. But it's usually the easiest because people are avoiding it. That's what you should learn and solve. If you see it in the exam, solve it. If you see portfolio, do it because people is avoiding those ones. Do you understand? So we have natural log S 200 over 220 plus R 0.06 plus 0.5 standard deviation multiplied by, what's standard deviation? Okay, 0.5 square time 0.25 all over standard deviation 0.5 root time 0.25. Put your values carefully, then start putting in your calculator. So you start from here, okay? 200 divided by 220, that gives us 0.909. So we still have the natural log 0.909 plus, now be careful here, start from, this will be the last thing you would undo. Start from here because this one like this is on its own. We dismantle this, multiply by this, then add to this. Okay, see plus multiplication. Don't start from plus, don't start from addition. Okay, multiplication comes before addition. So you multiply first. If you add plus or 3, just plus. If you add plus or 3, just do plus. Okay. So we do this first. 0.5 square, that's 0.25. Multiply by 0.5. That will give you 0.125 plus 0.06. That will give you 0.185. So you can use 0.185 to multiply 0.25. Multiply by 0.25. And that will give you 0.04625. So carefully write that 0.04625 all over 0.5 multiplied by this. So just say 0.5 root 0.25. That will give you 0.25. Does not make, it doesn't look okay. Let me do it one by one. Root 0.25, 0.5 multiplied by 0.5. 0.25 is correct. So 0.25. Now let's dismantle this. Natural log 0.909. Natural log is on your calculator here. Natural log 0.909. We have minus 0. Whatever. Just say plus 0.04625. And that will give us something divided by 0.25 minus 0.1966. Can you see that? So that's your what's it called, D1 equals minus 0.1966. And D1 equals 0.5 plus or minus table value. What is my table value? Is this your D1 you used to get your table value? You now flip to the back of your book and check the table value. How do you check it? 0.1 under 0.09. So this is what we're checking for. Let me use the black to write it. This is the figure 0.1966. If you watch the previous class, definitely you understand what I'm saying. So we're checking 0.1 under 0.09. Simple as ABC. Put it on the screen. Look at it. 0.1 under 0.09. Where did it intersect? What value do you have there? 0.0753. You carry it and put it in your formula. Is it clear? And D1 equals 0.5. Are we using plus or minus? Minus. Why? Because we got a negative here. So this negative implies that D1 is less than 0. This is the number line. 0 is at the center. Anything behind is even less than 0. Okay? So we have minus 0. So if it was here, you use plus. So because we have solved like 50 questions, you already know this, right? So we have minus that value we lifted, table value 0.0753. Okay, 0.0753. Like always check your figures, double check your figures, because 0.753 and 0.0753 are two different things. One is 70%, one is 7%. So you say 0.5 minus 0.0753, and that will give you 0.4247. Okay, so your ND1 is equal to 0.4247. You've gotten your ND1. This is what we've been looking for. Just to use it to divide this so we can get the number of contract to delta H to protect our investment. Put this value here, 0.4247, and that will give us, put that in your calculator, 100,000 shares divided by 0.4. That will give us 235,460 point whatever, right? 235,460 options. Now let's imagine that this thing was, let's say 1 instead of 0.4. Let's say the value was 1.0. Let's take it as a higher ND1. I just want to show you something. What we will have is 100,000 divided by 1, and we'll have 100,000. Can you see that it is lower? It means that the higher the ND1, the lower the risk. And the lower the ND1, that's the delta H, the higher the risk. It means this thing is very risky, right? It means you will need to, it means it's very risky. It means you will need to buy more contracts to hedge. And it makes sense because we said delta measures the change in option value with respect to the current market price. So it means that this delta, vega, they are all rates, because the rate of change to rate of, so is a rate basically. So it means that, let's say change in option value, let's say change in price is X and change in option value is X, then it will give you 1. Do you understand? So it's not very, I don't know how to explain it. But anything that is making you have 0.4, it means it's not balanced. It's not balanced. So let me see if I'm confused. Then the B part says comment upon whether or not such hedge is likely to be totally successful. Now, there was something they said in the question that assume that the option, close the door, sir. Close the door. Thank you. Assume that the option contracts are for the purchase or sale of 1,000 shares. So it's like you're buying it in bundles. You can't just go there and say, I want one unit. It's a unit of 1,000. So how can we buy a unit of 1,000 from this? How many 1,000? Lamari, Yombi, that's the meaning. It means you can buy, let me use a different color marker so that it will be clear. So we'll say based on the option contract, only you get the value, just write it somewhere, 235,460 divided by 1,000. Okay, that's how to know how many bundles you can get So from this you can get 235.46, right? Let me do that. That's what you get. So 235.46. But there's a rule in option contract. You cannot approximate upward. You cannot round up and say, okay, then we'll buy 236 contracts. It's not the exact value. There are 235,460 contracts needed to hedge. If you buy this, what will happen? I don't even understand. What will happen to the rest? So you cannot round off. You cannot round up. You can only round down. Yes. You cannot. Let me write it. Round up. You can't. You can only round down. Okay. So you have to remove this 46 contracts and say the approximate value is 236. This is your final answer. So I just put that by it. So I say based on the option contract of 1,000, only 236 contracts can be bought. Do you understand? You are buying one contract and it's sold in 1,000 units, what they call one contract, like a bundle. Based on this question, in some questions it can be 50, it can be 100. So you can buy only 200 and what am I writing? 235. I just said you can't run. So you can only buy 235. So they are asking you that, do you think it's, what did they say? They said comment upon whether or not such hedge is likely to be totally successful. Honestly, it looks successful until we got to this part. So your comment will be based on the option contract. Only 235 contracts can be bought. Therefore, it is not totally successful. That's the 2 marks, and you will get your 15 marks. Okay. There is an excess. Okay. There's an excess 460 units of the contract that will remain unhedged. Do you understand? There's a fraction. You see, what is this 460? You can go further, like me. I'll say 460 over the total 235, 460. There's a particular percentage times 100,000 shares of that number of shares that will be unhedged. So that's all. Even if you don't get this particular answer, just be able to interpret your results, because financial management entirely is about estimation. That's why I like it. You don't have to get the same answer. Just be able to interpret your results. And that's all on the Greeks and delta hedging and all that. The next part that we'll be talking about is real options. I don't like long classes, but I promise to drop the next class, like in the next 48 hours by God's grace. Real options. So let me just introduce that. Real options focuses on the application of option pricing theory in investment appraisal. Now, the real deal, that's the real deal. What are we using option pricing? What are we using option pricing for? Is for investment appraisal. So in a situation or in a question, you can have different situations, actually 4 situations. Based on your question, the question you get, in this aspect, you can have 4 situations, which I abbreviate as DM. Okay? In every question you get, ask yourself, what is the situation? What's happening? Is it a delayed decision? That's D. Or expansion, abandonment. So these are the 4 situations. Then number 4 is redeployment. It's very simple. Delayed decision is like, oh, in the next 3 years we would invest. You're postponing a future cash flow. That's it. So this delayed decision is a call option because it means to buy. Call means to buy, so you still spend that money. Expansion is a call option because you spend the money, you would invest. Abandonment is a put option because you are abandoning, you are selling, you are disposing, so it's a put option. Redeployment is a call or put option because it depends on what you are doing with the extra available resources. Did I say abandonment? Redeployment. So the reason I explain this is because in the question, we solve a question in the next class. In every question, if it is a call option, those 5 key variables, they represent different things. You know, the option pricing, so value any option. These are the 5 key variables now. And every option pricing theory, you are either asked to value an option or to delta hedge. That's everything involved around. So if you see a question, the first thing to ask yourself, let me give you steps, okay? Step 1, what is the situation? Meaning, what is the real option? These 4 things are called real options. What is the real option? So when you read the question, Bakari investment in the next 3 years, they choose to sell off a product, a project or a part of the business, or in the next 2 years, they want to put in 50 hours of unskilled labor into this. You know that is they are redeploying. Or they say in the next, from the beginning of year 3, they want to involve, they want to maybe advance capital expenditure. You just read the question. They won't tell you delay. They won't tell you expansion. They won't tell you abandonment or redeployment. But when you read the question, you would understand it. So after you know the real option, okay, this is an expansion. Then you now say, then you name the option. Sorry, you name the option. Is it a call or a put? So after you identify the option, the real option, you name it. Is it a call or a put? Then number 3, identify the 5 key variables. You know, you think this is current market price, this is, no, in real options they are different. They mean different things, and I'll give that to you. So for this S, it is either under a call option or a put option. Right? So we have S, we have E, it's just S and E that is different. This one remains the same, this one remains the same, this one remains the same. So under a call option, the S that you know as the current market price, under a call option, it is going to be, I'm trying to remember. I'm going to post this video in real time, I won't cut out anything. S is going to be present value of future cash flows. Yes. So just placing the add information at the tip of my fingers, no. Present value of future cash flows. That's it. I'll explain why. Now, E in a call option is what you know as future price, what you know as exercise price, right? It is investment value. Okay, or let's just call it initial investment. You know, it's a call option, meaning you buy, you are spending money. So that initial investment, at the start of year 2, we would invest in this. Maybe you delayed the decision. So it's a call option. You know it's a call option. So you ask yourself, what is my S? My S is the present value of future cash flow, meaning today's value of those values I intend to get in the future from the investment. Does it make sense? Remember bond valuation and all those things. Now, E, the exercise price, the future price, is the initial investment, right? It makes sense. This one remains standard deviation risk. This one is still interest rate. This one is still time. Now, this one can be very tricky. This time can be tricky. If it is a delayed decision, it is between now and when that investment is going to be delayed to start. Okay, there's a question in it, so we will understand it better. Now, for put option, S in the put option is S in the put option is the present value of foregone cash flows. Click the link in the description box to download the exam bullets. So these exam bullets are like a summary of, you don't have to come back to watch the class. You've watched the class, you've solved questions, you understand. The reason I remember this is because I had exam bullets. Do you understand? Where you used to, like, you know how you summarize something in your notes. Do you understand? Because the classes can be voluminous, but you have them summarized somewhere, you're able to remember. So this is present value of foregone cash flows. Because put, you sell, you abandon, so you what's the past of foregone? You forego some cash flows, right? So this is today's value of those cash flows I would have gotten in year 3, year 4, year 5 if I had not sell at the beginning of year 2. Do you understand? Then the E here is the abandonment value. The moment I disposed that plant, what did I get? The cash flow that came in. That's what we call abandonment value, or sales value, or disposal value. Disposal actually. Yeah, disposal is the correct thing. So this ones remain the same. Standard deviation, interest rate, and time. Just like call option is the initial investment, how much you spent. In put option, it is how much you got. The S is present value of the future cash flows. How much would I get from that investment? Look at this one. It's not how much I will not get, how much I forhold. Understanding is key. When you understand, it's easy to recollect. So in our next class, we're going to solve two questions, so that you can establish an understanding of this topic and we can say bye-bye to it and start Forex. Don't forget to share this video to your group chat to someone that will find it helpful, and I'll see you in my next class. Bye!